This is a talk we gave in the OpenStack Summit in Vancouver. And the question I asked at the beginning of the talk was, how many of you know what Jenkins is? If you raise your hand. How many of you know what CI/CD is? Great, we're all in the right room. That's perfect. My name is Maish. I'm a platform architect at Cisco here in Israel, in Jerusalem. I have been working with virtualization and OpenStack completely for the past 2 through 3 years. And this is Naama.
And my name is Naama, working in Cisco for almost 3 years. I'm a software developer, working in multiple cloud environments, concentrating in OpenStack in the past year, trying to develop tools that will make CI/CD in OpenStack environment a little bit easier. I think that Painless is a little bit strong for the concept. And with me and here in the audience are Einav and Adiel. You can see the emails, our 2 colleagues from the team. And all the code that we'll demonstrate here is uploaded to open source. You can download it, try it, and if you have any issues, you can use the emails of Einav and Adiel.
Or us in the beginning.
Or ours.
So a tiny bit about Cisco, and I promise this is the only marketing we're going to be doing. It's not even marketing. Cisco is involved in OpenStack in a number of different forms and different ways, from actually how to actually use the OpenStack, providing plugins and different additional technologies for the operations and management, of how to connect OpenStack clouds one to another or to different cloud providers. And the third part is providing tools how to use and build things with OpenStack itself, and that is specifically what our talk is about. And I apologize if I'm going to be very quick, because the talk we originally planned was for 40 minutes, and here we have 30, so we're going to go pretty quickly. Yeah. So we build RPMs. We have a very big development organization which do a lot of code. They build RPMs. There are a lot of teams which work in different geographical locations, different time zones. They write a lot of stuff, checking code a number of times a day, and everything like that is supposed to eventually be made into a working shipping product, which is very well oiled together, very well coupled together, and unfortunately very, very tightly coupled together. So what do we want to do? As opposed to a number of other people using OpenStack for CI/CD, a lot of people using OpenStack CI/CD in order to test OpenStack on a regular basis, continuously deploy OpenStack and continuously test upgrades and so on and so forth with OpenStack, the software. But we were looking at how to use our current CI/CD pipeline, which we already have, because this is what we are a very, very big development shop, and incorporate OpenStack into that pipeline as part of our workflow, as part of our compute resource, in order to do all our tests, all our packaging, and so on and so forth for our environments. So, just to make the field a little bit straight, we're talking about 3 different kinds of things. Components are a number of RPMs which are packaged together. A number of RPMs are packaged together into one product, and there can be a number of components, and we're talking about a number of something like 10 to 15 to 20 different RPMs can make up one single product. And all of these packaged with a number of different products can be packaged into one single solution, which should be deployed as one single workflow, which was our biggest problem, because up until now the whole thing with using OpenStack was everybody was providing ways to use OpenStack as a CI resource, deploying virtual machines, not using heat templates, which we were required to do, because that is how we are deploying all our packages and our solutions today with our customers, using heat templates.
So one of the concepts we introduced is a modular heat template. The problem with a heat template is that when you have dozens of components, dozens of RPMs, each of them in configuration file, which may have dozens of configuration lines, it can get a little hairy. And if you have to maintain changes, if you change one component, one RPM, and then changes require changes in configuration, and then you upgrade your heat template that let's say sits in some Git repository, and then you change another one, then you roll back one. But when you roll back both changes for both components. So what we decided to do, and that's what we support in our plugins, is to separate the deployment model and network topology to the actual installation of each component. The heat template includes only the deployment model and networks, scaling groups, etc., but not the actual code that deploys every application. The code that does deployment sits with each component. We upload our components to a Maven repository. We currently use Nexus. So in our platform, whenever we upload an RPM, we upload the deployment code with it as a sibling artifact to the Maven repository. This gives us three things. One is reuse. If you use the same component in different contexts, you can reuse the same deployment code. The second thing is ownership. The developer is the one who owns the deployment code. So if there's a problem, it's his responsibility to fix it. When he does a change in the code that requires configuration change, it's his responsibility to change it. And the last, and I think most important thing, is versioning. Each component has the right version of the deployment script. If you go back to an old version of the component, you get with it the matching version of the script. You can match or just collect the right versions you want, and you have the exact scripts that go with each component.
And it sounds complicated because it is. It's not a very simple task to do. But why did we want to make this complicated? And not complicated. We want to try to simplify everything, but it was a complicated exercise. So this is where Jenkins came in. Jenkins was our glue between all different parts that we needed to match between each other, between our repository where all our artifacts were, where we store our artifacts, which Naama said is Nexus, and we also added in as of late, Artifactory support as well. We used our code repository in Git, and we used OpenStack as our compute resource. And Jenkins was the one that tied every single one of these pieces one to another. So in the plugin, we have 4 steps. We first define a product. Then, when we build the job we define, we generate the artifacts required for this product. I'll go in details on each step. Then we define what the deployment should look like, and then when we execute it, we actually do the deployment on an OpenStack environment. When we define a product, we define what RPMs are required. If we have any dependent products, for example, if we have a web application, we may have defined the database tier as a separate stack. So we want to install first the database tier, and then deploy our web heat stack. So we define them as different stack, and then create dependencies between the two. We also define what the heat template, and we use Puppet to do all our deployment, to do our installations. So Puppet scripts are also part of the product definition. The next step, when we build this job, and we'll see it in a minute in the demo, we first resolve the version. When we specify what RPMs we want, we can specify it in 2 ways, either a fixed version, or as required in CI, say, please give me the latest, or even the latest snapshot. Don't do it, but it's an option. So we resolve the version, we download all the dependencies, or the Puppet scripts that are accompany each RPM. Then we generate artifacts. We'll see it in a minute in the demo, a POM file, a tar file, and an RPM that define this product. And then we upload everything to Nexus or to Artifactory. Then we define the deployment. We define what to deploy, where we want to deploy it to, and also what YAM repository, which can also be Artifactory, we want to use for the deployment process. Then when we execute it, we do a few things. First, if there's an old stack, we kill it. We kill it now and not in the end of the process, because in the CI process, we want to enable the developers to check if something got wrong. So whenever we rebuild the whole system, we delete the old stack. We then download all the artifacts. We move everything to the YAM repository. We configure all the metadata required in the YAM repository. We load the stack. We set all the parameters if it's a parameterized stack. We call OpenStack to create the stack, and then we wait until the stack is created. Maybe we'll, I don't know if we have a few minutes, okay, yeah. So we have a few requirements on the heat stack, and this is again work in progress, and we try to eliminate these requirements. So right now we require a specific pattern for the files in order to recognize them when we load the stack. So if you have a product called XX, then we expect a YAML file called XS.YAML, and then the environment variable to be in XS.env.YAML, and all the dependencies file to be in a subdirectory. And we do not allow multiple levels, but this is something that, if anyone wants, can extend, of course, the source. And then the rest, I think I already talked about. We pass the YAML, we replace the parameters, and then we use the REST interface of OpenStack to create the stack. So the one question which we asked ourselves at the beginning when we started down this journey is why do we need to create a plugin which is something which doesn't, firstly because it didn't exist at the moment. At the time when we looked at this whole process, approximately 8 months to a year ago, there was a very, very basic OpenStack plugin for Jenkins, and the biggest problem we had, of course, was it did not support any kind of heat functionality whatsoever. Even if there were other kinds of plugins which did do that kind of thing, we didn't want to use the command line. We wanted to write something which was more modular and something which is more flexible and suitable to our needs. We checked out a number of options which were, for example, going to use, as we say, CLI. There was another a Java library, because we are a Java shop mostly, called for JClouds, of course, and also OpenStack for J. But at the time, those things still had limitations. For example, JClouds was only experimentary support for heat, and at the time also for OpenStack for J did not have heat support. So we wrote our own. So one of the things, of course, is we have nested templates. We have a number of templates. As we said, our things are made out of components into packages and into products, and then into solutions. So we have there are cases when we deploy a full solution, we need to deploy multiple stacks and do some wiring in between them as well. For example, if I have a database architecture and a web application and a database backend, I need to wire them together to tell my web application where my database is. And that's what we also use Jenkins for in this case. We also could use Jenkins to order, in other words, in which order or which at what point in the process each one of these things would also be deployed as well. And this, of course, was done by input and output parameters from heat, which is something which is built in by default. We would take the output parameters from one stack and pass them at the same values when the other heat stack would accept those heat parameters, and we would be able to do the wiring in between.
Okay, so let's see the demo. So we recorded the demo because we don't believe in demo gods. Sorry. Okay, so what we'll try to do is to create a stack that contains only a single guest, including Nginx. So we'll look here in the Nexus Maven repository. This is Nginx, which we uploaded to Nexus. We can see that in addition to the RPM, it has a Puppet tar file. Let's open it. It obeys my commands. Yes. So let's see what's in there. It's a very simple Puppet script. Let's look at the init.pp file. We can see that we install the Nginx package. We change a little bit the landing page, index.html, and we use a higher parameter. Nginx user will see how we bubble this parameter from Jenkins to the heat template to this Puppet script. So this is, we won't look at the template. It's a very regular one. So this is Nginx, and it already has the Puppet scripts. Let's now go to our Jenkins server and define the job that packages this single component in a product. So we'll create now, just to make things nice, we'll create a folder. We'll call it demo. Folder, more down, up, yes. And then we'll create now a new freestyle project called create. So here starts the interesting part. And here we'll see, we already installed the plugin here. We have a new build step called create product. And in the configuration, we can see we give it a name and a group ID so that we can upload it to Maven repository. So we'll call it demo product, and we'll use the group ID that our Nexus server is configured to identify. And here we can see the Git repository. This is the heat template Git repository that has the constraints we talked about. We don't need any other deployment scripts. We also support bash deployment scripts, but we won't use them here. And these are the Puppet scripts. These are not the Puppet scripts that install the component. These are libraries, generic libraries which are used across components. We can add here dependent products that we said is if we've had different stacks that our stack depends on, we could have added them here, and then we would have identified each product by its group ID, artifact ID, and version. We will add now one artifact, the Nginx component. So we'll say what it's group ID, artifact ID, and then we'll say, please give us the latest version. Latest means latest release. If we would have had RPMs which are not saved in Nexus, we could have added them here. It's not recommended. You should have all your components uploaded to a Maven repo, but we could, and then we should have provided here a HTTP interface to get it. So now let's build the product and look at the console to see what happens. So we can say first we look what the last version was and we upgrade it. The new one is 100.25. Then we resolve, we ask to get the latest Nginx. So we ask Nexus what the latest is and we get the 1601 that we just saw before. The next step will be to download the repositories, the HIT repository and also the Puppet scripts. We download not the RPM itself, this will be done in deployment time, but the Puppet scripts that accompany the RPM, and we package everything together. Then we create 3 artifacts. The first of them is our external dependencies, tar.gz, which include the HIT scripts, and if we would have had also other RPMs which are not in Nexus, they would have sit here. An XML file, a POM XML that defines all the dependencies, what components we need, and then another RPM that collects all the Puppet scripts from all the components and also all the base libraries that we took from the Git repo. Let's now look at Nexus to see our new product, 100.25, the one we just created, and we can see the 3 artifacts. The POM file, let's look at it. That includes the group ID, artifact ID, and our new version 100.25. And in addition, our dependency. We have only a single dependency, Nginx, and we can see here the specific version because this artifact defines a specific product that can be deployed. So it should never say here latest. It will always specify a specific version. And then in addition to the POM, we have here the tar.gz file, all the dependencies. We don't have any other RPMs which are not in Nexus, so we'll see here only the so the HIT script. We can see here the demo folder in it, and inside it will take a few clicks now. I think another 4, 3. Should have cut this really. 2, 1. Okay, so we can see here the the HIT template. Let's look at it now. The demo YAML file. Oh, this is the end file and the dependencies. So we'll open the YAML file. Just it's a very simple HIT stack, a few parameters, and then we have one server, one floating IP, which we define, no scaling group, single server. All our instances and all our guests call the same Bootstrap script component installation, and the difference is in the parameters, what components should be installed and what parameters. We can see the Nginx user, Nginx user parameter, which we used in Puppet. We can see it here, sent to the Bootstrap script of the component. So this is the HIT template. And if we would have had more RPMs, they would have been in the same tar file also. And then the last thing that we have here is the RPM that includes all the Puppet scripts. We collect all the Puppet scripts, combine them together with the base libraries, and then we create an RPM so that we'll always access the outside world using yum install. So here, we can see the Puppet script, we can see the same Nginx one that we saw before in Maven. So let's go back to Jenkins and define the next job that actually does the deployment. So we'll define a new job called deploy, another freestyle project. And in it we'll define one build parameter because the which build number we want to build should not be part of the configuration. It should be defined in runtime. So we add a string parameter. We'll call it version. I won't give it a default value because I want it to pass the parameter each time I do a build. Now I add a build step, the deploy product build step. And here there are three things which we define: what to deploy, where to deploy to, and what YAM repository to use for the deployment process. So what to deploy, we define here the group ID and artifact ID of the product. I don't define the version because, as I said, this is a build parameter. So only group ID and artifact ID. OpenStack credentials, where to deploy to, IP, username, password, DNS server in order to register internal DNSs. I can also test the connection, and then I can add advanced parameters. Some of them are standard, like the keeper to use, private network ID, subnet ID, and some are user-defined. Let's now add we'll add a user-defined parameter, our Nginx user parameter that we saw in the heat template and in the Puppet, and the value will be Maish. And since we use a public IP, then we need also the public network ID, so we'll set it here also. We define where there are other parameters in the heat stack, which we should define, like node configuration, what image we want to use, what flavor, minimum and maximum for the scaling group, if exists. We don't use it in our stack. And then we'll add now the one availability zone that we use. We can add a prefix to all the parameters. We don't need it here. And then the last thing is the YAM repository. In the version we're going to upload to the GitHub in a few days, we'll have also the option of using Artifactory YAM repository instead of our standard YAM. If we use standard YAM, you will need the IP and also the private key in order to push files to this YAM repo machine, which we expect to have Nginx, very simple configuration. So let's now execute, Let's now execute this job. We'll put the version 100.25, the new one that we just created, and let's look at the console. So the first thing that we do is to kill the old instance. Yes. So we send OpenStack a request to kill the instance and wait until the status is undefined. Then we download the three artifacts from Nexus, the tar, the RPM, and the POM, extract the tar. The data that we miss now is the actual RPMs, which are described in the POM file. So we download these RPMs. In our case, there's only one, the Nginx 1601 RPM. So this one. So we download the RPM. We have the RPM, we have the additional ones when exist from the tar, and then we move everything to the YAM repository. We configure the metadata. We then load the stack. We replace the parameters. If we would have had parameters from previous stacks set as output parameters, we would have used them also. And then we call OpenStack create stack and start polling OpenStack every minute in order to see if the stack is done. Let's look at the YAM repository just for a minute, the one that we configured. And we can see here in the packages, this is the RPM that we created from all our Puppet scripts and also our Nginx RPMs. These are the two RPMs that we use as part of the deployment. We'll open now the OpenStack Horizon to see the stack status. And this is our demo stack in progress. Here, there's the only cheating I've done through the recording. I fast forwarded for 2 minutes. So we'll see in about 5 seconds that we're done. Or more. So we'll see now that we wait until OpenStack tells us that the stack is complete, which is now. Oh, it's fully complete. And now let's go back to the horizon. Let's look at our stack. To see in the overview I didn't mention it, but we've set the output parameter to see the landing page of our Nginx. And if I open it, I can see now the hello Maish inside the landing page, and this is the stack we created.
So we have another 1 or 2 minutes and 2 minutes. So quickly just go back to 2 last things. So where you can find the actual plugin, over there is the link. This, of course, presentation will be available straight after. It already is available from the previous summit, but we'll post the link again, where you can take the link, open source, please download, make changes, push pull requests back so we can also continuously improve. And excuse me, another link, of course, for the Cisco GitHub repository, which also has a number of other things, specifically also for OpenStack and other projects which are going on. And since I think our time is up, we're not going to take any questions, but we will take them offline afterwards. Please feel free. As I said, the presentation will be available afterwards, and thank you very much for your time.